In this video, we're going to look at a couple different examples of how to factor quadratic expressions. The way we end up factoring our quadratic expressions is with using both a generic rectangle, which we have here, and a diamond problem, which we have down here. Now what we're given in this example is the sum, right? 2x squared plus 5x plus 3 is the sum, and those are the values that need to fill up this generic rectangle. In general, we know that the 2x squared is always going to go, we tend to always put it in the bottom left box. And then the 3 is going to go in the top right box. So our work that's left is to figure out what should go in these two boxes that are remaining in order to get you to 5x. Now, you could probably guess and check your way to do that, but what we want to do is try to find a systematic way to be able to do that every single time. We also know that if you take the product of 2x squared times 3, you are going to end up with a 6x squared. And what we've discovered in our other work that we've done so far with our generic rectangles is that both those diagonals, when you multiply them, need to equal the same thing. So this also needs to equal 6x squared if we were to multiply the bottom right box by the top left box. Those products must be the same. And so that's how we create our diamond problem. Say, well, we know that the product of those two numbers has to be a 6x squared. We also know that the sum of those two products, when you add all that sum, because you add those parts, has to be 5x. So whatever goes in these boxes here is going to add up to be a total of 5x. So now we have a product of 6x squared, a sum of 5x, and we know, hopefully, that the two things that multiply to 6x squared and add to 5x are a 2x and a 3x. So those are the things that are going to fill in the boxes of our generic rectangle. So you put a 2x in one of the boxes, a 3x in the other box. And it does not matter which box you put those in, as long as you finish the rest of the problem by factoring. Once we're at this point, you can take a look and say, well, I've got a 2x squared and a 2x. What can be pulled out of both of those? And that would be a 2x. If I do so, on the bottom, this has to be an x in order to get 2x times x to be 2x squared. And as I continue my work, this on the bottom right has to be a 1 because 2x times 1 is 2x. And then this has to be a 3 in the top left because x times 3 is 3x. And now we have created a systematic way to come up with the area as a product, which would be 2x plus 3 and then multiplied by x plus 1. So in this process, what we started with is taking your x squared term, putting in the bottom left, your 1's term, putting it in the top right. Then you multiply those to get a 6x squared in this example, and that product is always going to go in the top of your diamond problem because that's what a diamond problem is created by. The last part is to figure out the 5x, which is the sum of these two boxes. So that's why we put 5x in the bottom here. You complete your diamond problem and take those values on the left and the right, complete your boxes or put them in those boxes, it doesn't matter where, and then factor out to find the dimensions of your generic rectangle. So let's look at one more example quickly. So we have a 3x squared and an 8. So 3x squared goes in the bottom left and 8 goes in the top right. We know that if you were to multiply those by each other, 3x squared times 8 is going to equal a 24x squared. That's the product that has to go in the top of your diamond problem. The last two boxes that we haven't filled in yet need to add up to be 10x. So we know that the sum has to be 10x. The values that multiply to 24 and add up to 10 would be a 6x and a 4x. If you struggle with that, you can find all the factors of 24, which would be 1 and 24, 2 and 12, 3 and 8, 4 and 6, and there's no more. And then you look at for what the sum of those is going to be in order to add up to be a total of 10. So you can just start listing, starting at 1, going all the way up as far as you can to finish your diamond problem. So to finish the generic rectangle then, it doesn't matter where you put those yellow values, 6x and 4x, put them in those remaining boxes, and then you think about what can come out of a 3x squared and a 6x. That would be a 3x in this scenario. And then the bottom, that has to be an x in order to get 3x squared. This bottom right has to be 2 in order to get 6x. And this has to be a 4 in order to get 4x in this top left because 4 times x is here. You can always double check your final work. 4 times 2 is 8, and so this works. For our final area as a product, you would end up with a 3x plus 4 multiplied by an x plus 2. As stated earlier, you could of course guess and check your way to try to find out what the area of a product is, but once you're given a sum, and I want to find the area of the product, the generic rectangle and the diamond problem are a surefire way to always get you to the correct factored answer.